time because I'm bound to be controversial at various points, and some of you are going to wonder why the hell am I doing so much about Marx. But I want to give you an outline of the two areas I'll be covering in today's lecture, and the overall what I hope to cover over the next 11 lectures as well. And the first couple are going to be on the physical and philosophical foundations of the approach I take to economics, which ties in what's called value theory. Has anybody you've heard of the concept of value theory? It's one of those things which is both talked about and misunderstood, I think, completely through economics. Thermodynamics. Who's seen anything on thermodynamics? Any? A couple? Okay. And dialectics, which is Marx's philosophy or Hegel's philosophy of social change. There'll be a history of economic thought segment after the first couple of lectures where I try to explain where Minsky's views came from. So Minsky, there's a long story. Marx was actually the foundation of Minsky's thinking. You won't find a single reference to Marx in his writings for a simple reason. Anybody tell me why? Living in America in the 50s, absolutely. It was good for rock and roll and lousy for politics. Any mention of Marx, you were out the door. You had to go before the House Committee on Un-American Affairs. You'd lose your job, etc., etc. So he did not put a single reference to Marx in any of his writings, even long after Joe McCarthy was thankfully dead. But my own little personal history here is worth my career recounting now, I suppose, rather than later. I've become friends with Minsky's family, particularly his son, Alan, and I wrote Debunking Economics in Minsky's room in the Bard Levy College when Alan was also there. And I could feel so much of Marx in what Minsky wrote that I just asked Alan, what's the background? Obviously your dad had books there because his parents met at a Communist Party function in Chicago. They were both non-Bolshevik Marxists from Russia, escapees from Russia before the Stalin purges began, but that's how they met. So of course there were books of Marx in Minsky's house. And Alan, like a lot of his sons, was estranged from his father. Not estranged, but they didn't have an easy relationship. So Alan went into media and things like that, and indie media. And then in his 30s, he became more interested in economics, which was his dad's area, and getting a good working relationship and family relationship with his dad. He said, if I was going to read economics, where should I start? He said, Dad went into the study and came out with a book and gave it to me. It's Volume 1 of Das Kapital. Okay. So that was Minsky's foundation. But Minsky took a very different reading of Marx, again, I think, to most conventional Marxists. So I'll be giving the history of how he went from Marx in the background, without ever admitting it, through Irving Fisher, who was the first person who gave him a theory that I think really gave him an organising principle for his vision of how the economy became financialised, through Schumpeter, who was his PhD supervisor. And there's clearly an enormous impact by Schumpeter on Minsky's thinking, so that'll be probably one or two lectures there. Of course, to get there, I'm going to give you a lengthy interpretation of how I think about Marx, and I see that as a prelude to a very structured and classical economics in the sense of the coming out of the tradition of Ricardo, Smith and Marx, non-neoclassical. So I think in terms of how the theory of value has developed in economics, we've been dominated by the neoclassical vision and the Austrian vision to some extent, which sees value as something subjective. Okay? Value, you talk about the value of something, people talk about the utility, and you've all learned about marginal utility, etc., etc. It's all a subjective valuation. Marx and the classical school start from an objective theory of value. Value is about effort, not about utility or pleasure in that sense. But there's then a real challenge for different disciplines. How do you handle various elements of reality when you start from one position, which is, say, either subjective valuation or objective valuation? How do you handle something which has the opposite characteristics in some ways? So how do you start from an objective theory of value and handle things like people being early adopters of technology and the price they're willing to pay for new technology? I'm guilty of that, okay, well and truly. I pay through the nose for new technology, quite willingly. And you're not going to explain the price. I pay all the price that the early technology developers will do on an objective cost of production. I'm paying far over the cost of production. Equally, if you start from a subjective theory of value, how do you handle things like production? How do you explain the dynamics that occur between one industrial sector and another? And that's led to what we call the capital controversies for the neoclassical school. In a lot of ways, the problems for the classical school are how do you go from an objective theory of value to handling things that have a subjective content. And what I'll be explaining is how I see that's quite feasible working from Marx's philosophy, which begins from an objective foundation but can handle subjective elements later. And finance turns up as one of those subjective elements. Then I'm going to go through the financial instability hypothesis, both in how it's developed and a verbal explanation, and the mathematics. Now I'm going to try to make that as straightforward as possible. Anybody who freaks out with maths, shut me up when you find I'm going over the top, okay? Tell me to slow down, and I'll go back and try to cover it. So I'll go through the basics of how dynamic systems are built and how they're analysed, how you work out what's going to happen with the dynamic system over time, whether you can work that out. Okay, there are elements where you can't without doing a numerical simulation. And I'll take you through system dynamics using my software package Minsky. Has anybody here downloaded Minsky? Okay, a few, right. I'm going to get you all to do that at some stage because I'll have one exercise which is going to be using Minsky to build a simple set of models and get a familiarity with dynamic modelling that way. And you'll be caught up in what's called complex systems analysis as well. So a huge part of modern approaches to biology, physics, chemistry is based around the idea of interacting systems which have outcomes that you can't define by working from the isolated elements of those systems. And I want to explain where that comes from as well. And of course the central role of money in the whole phenomenon, and then the economic policy implications of all that. So that's what I have to go through in about 11 lectures. But we'll see how we get there overall. I'm starting with value, and the question is, why do I start with value? Well, one of the essential points of the argument about financialisation is that over time the output of the economy is more and more commanded by the financial sector. And we've certainly seen, anybody living in London can see that. But we have to therefore first of all know, how do we produce that surplus in the first place? In effect, if you start saying, well, the financial sector does this over time without exploring how does the surplus get generated in the very first instance, you're starting halfway through the question. I want to go back and say, well, where do we actually manage to produce the surplus of not just money but also commodities, initially commodities? How do we produce more output than input? Okay? That's, to me, the essence of the question of what is value. So the essence of what we do in an economic system is not every year, clearly. We're going through financial crises right now, so it doesn't happen every year. But capitalism's history has been a growing output over time. Now, some people will say that's because you've been exploiting the third world and taking goods in here, etc., etc. That's why. So it hasn't been a growth, it's been an exploitation. I'm sorry, empirically reject that. The period of the initial growth of, the period of initial growth of England and the industrialisation phase when it started to use coal really had nothing to do with what it was doing to the colonies at the same time. The colonies really developed as something that happened in England after 1840, 1850. There had been 60 years before that of a dramatic expansion in England's industrial output, which was based on what was happening in England. So, to me, this is the essence of capitalism. We've had this whole period of producing more outputs, most years, than inputs over time. And the system has grown not just in absolute terms, but per capita as well. Pardon me, sort of hand gesture. So how's that possible? And that's really the topic of value theory. How do we actually produce more outputs than inputs, except, of course, during financial crises? Now, every school of thought has its own answer to that, but more importantly, they've got their own definition of value as well, and sometimes that definition of value takes for granted that a surplus is produced without actually explaining why. By the way, I'm going to go far too fast for people to take good notes, but I'll put this up on Study Space when I've finished, okay? And this particular lecture has got about 140 slides in it, which I know I'm not going to get through today, okay? But what I'll do is I'll be editing that for next week. So it'll be the first version I'll put up today. There'll be a different version for next week where I'll continue on sort of halfway through. Now, thermodynamics I've mentioned as well. And that's because this is something that was not known by the developers of economic theory when they started to develop economic theory. If you go back to look at where economic theory began from, really the first economists I'll be talking about began in the mid to late 1700s. The classical school, in a sense, began with Smith in 1776. You had Ricardo in 1817, you had Marx in 1846-47, etc., etc. Thermodynamics was really trying to explain the behaviour of physical substances, in particular gases, starting in and that began in the 19th century. In some ways, I think the first was a guy called Carnot, not Corno, but Carnot, talking about the behaviour of engines and heat, how one can produce work out of an engine subject to being heated. So there were simple steam engines long before James Watt. So Carnot, who was French, was the first to really try to work out how do we actually get energy out of this, how do we get work done by a machine, and what are the limits that a machine can have of producing work out of energy inputs. Now, this is really where we manage to produce. And if we have an answer for where value comes from, it's incompatible with the theory of thermodynamics, then it is wrong. Period. No debate. Okay. People will talk about the law of value, or they'll talk about the law of comparative advantage, etc., etc. Economic laws. They're almost universally broken. Okay. Comparative advantage, you look at the history of international trade, it's a fallacy. Law of one price, another fallacy, etc., etc. The laws of thermodynamics are not a fallacy, they're absolutely true. Any attempt to say you can break them, or you have a theory which is not compatible with them, then you have a theory that is wrong. And I'll try to explain why that is the case. I think only one school in the history of economic thought ever came close to being right, funnily enough, and it's the very first, the Physiocrats. Has anybody heard of the Physiocrats? Some? Good. Who hasn't heard of them? Right, okay. I wasn't certain how much I should cover here. I'll probably do more on the Physiocrats when I revise these lectures for next year. And finally, dialectics. Our ambition should be to build a coherent theory of everything economic. That's what we should be trying to do. And you look at every school of economics, that's what they try to do. Now, I believe that the only way that can be done is by starting from Marx's dialectics. The only organising principle, yeah. Severin, yeah?
I remember hearing that there was a certain amount of debate about at least one of the laws of thermodynamics related to the question of whether or not complete recycling is possible for Wigan was.
Yeah, and it's not. Complete recycling is not possible. Period. There has to be waste, and actually there's not just waste. Normally you talk about waste energy, but there's also waste matter. There are some elements of matter which simply can't be used. So there are things which are simply poisonous, which are produced as byproducts. But the main thing is that they're energy which you simply can't use. There's a certain amount of energy which exists like if you have a lump of coal, for example, you can specify the complete energy content of that lump of coal. And you can also specify that there's a certain amount of energy you cannot harness to do work, which is really what we're talking about when we're talking about economic activity, work to transform something. So there's energy you can't actually access. So back to Marx, I think to get this philosophy of everything, economics that covers from the objective conditions of production through to the subjective nature of finance and innovation and so on, I think it's the only organising principle that works. And it's what's really driven the approach to economics I've followed for the last 40 years or so. But it's very non-standard. Okay? I'll get lots of opposition to my interpretation of Marx from both people who are critics of Marx and people who are fans of Marx. Okay? So this is not stuff which the one reason I've got to go into all this detail is to give you that background fully. Now, every school has got a different definition of value, and the neoclassicals and the Austrians begin with the idea that value is subjective utility one gets out of consuming something. It's very much an orientation to the individual, where every individual is different, and where you can't compare the utility one person gets to the utility somebody else gets from a commodity. And that's inherently why the neoclassicals have such a problem trying to do such a simple thing as derive analysis of market demand, which they fail to do. Okay. They don't tell you that, but they do fail to do it. What they start from is saying that increasing value means increasing utility. I think the best statement of this is made by Jean-Baptiste Say. Who's heard of that name before? He was an early rival of Smith and Ricardo more than Smith. But they were good friends, but rivals at the same time. And Say distinctly had a neoclassical orientation. He was saying that the way that you create value is by giving something more usefulness. Okay, by adding utility to something, you create wealth. That's the vision that Say had, and that's really the vision that neoclassical economics has today. The post-Keynesians, which is largely the school that I'm identified with, is rather agnostic about value, and really it's because there were just huge fights, intellectual fights, between neoclassicals and classical theorists back in the late 19th century. And the post-Keynesian, and also this continued with Marxists in the 20th century, critiquing neoclassicals replying with critiques of the Marx through the transformation problem and so on. It would just look like a mess to post-Keynesians, who generally tend to be more pragmatic in their approach to economic theory. So in some ways they become agnostic about it, and they simply take that output grows. That they basically say output can grow over time, just take it as a fact, and then we analyse the distribution and potential crises and so on. So they're outside the whole discussion. The classical school began with an objective definition, and effectively what they see value as is embodied effort. I'm not saying embodied labour there, because I haven't got the quote from Smith in this set of slides. I'll have to add it later. But Smith, when he talked about labour and talked about farming, argued that farming was more productive than industry because, and this is pretty much a quote from the Wealth of Nations, not only his labourers, but his labouring cattle are workers. So effectively, Smith saw the animals as contributing work in the same fashion that the farm labour did. Okay, so it's an effort theory of value, not a labour theory of value. And Smith argued that the increase in value comes from dividing labour up more finely, getting a better division of labour, and the specialisation increases the physical amount of material that can be produced. So there's an objective theory of value, there's an embodied effort, and increasing value means producing more stuff, and the way you produce more stuff is by the division of labour. Now, Marx, before 1857, saw value as embodied labour, not effort alone. It was the work of workers, and only the work of workers, generated physical output, value, and you increase the value by increasing the exploitation of labour. And I'm using exploitation in inverted commas there for a very deliberate reason. First of all, Marx argued that workers weren't exploited, in a sense that they got paid what the market system objectively required them to be paid, which was their value. Okay, and the value therefore defined as, and this is the effort definition, the value Marx defined as being the amount of goods required to keep a worker alive. So the value of a worker for one day with the means of subsistence for the worker for that one day. Okay? And he said workers were paid their value. In fact, he said they paid more than their value, which I'll talk about later in lectures here. So he began with that orientation. Now, on to thermodynamics. I want to cover that mainly today. I probably won't get through more than about this and a bit of the value theory argument here. But what thermodynamics is, and I've got a link to the Wikipedia page there. By the way, my attitude to Wikipedia is a bit ambivalent. I love to use Wikipedia for things that I'm not an expert on, okay? Or that I'm not doing research on. But if I need to know about it, then I find it a very, very useful resource. If I actually know an area and I've got Wikipedia, I can normally run a freight train through some of the arguments that are made in some of the sections that I know properly. But for things I don't know all that well, I'm happy to use it. So that's a link to the Wikipedia entry on thermodynamics. Okay. Now, what it fundamentally is the physics of how we use and transform energy. And it involves laws that are simply so empirically well verified and so well founded in physical experiments, mathematical analysis as well, that they're incontrovertible. They're not laws you can break in any sense. So I don't believe you can reduce economics to thermodynamics. Okay? I'm not arguing that. But if you have a theory of economics which contradicts thermodynamics, then it's like having a theory of biology that contradicts chemistry. Okay? Revise reactions that can't happen inside a cell to happen inside a cell to explain life. You haven't got a theory of biology if that's the case. even though biology is not chemistry. So I'm saying you have to be consistent with those laws. Now, it reached maturity in the mid to late, actually 19th century, pardon me, I'll fix it up straight away. Okay. I'm in the 1800s, of course. A little confusion. So it was neither influenced by, nor did it influence economic theory at the time. So what you have is the result that most economics is not grounded in these unbreakable laws. And I had my favourite personal experience of this was speaking at the United Nations Environment Programme workshop where we were presenting a piece of research, and the chief economist for that particular division, I don't know where he ranked in the United Nations Environment Programme overall, noticed the environment programme, so you should know about these things. And he made a comment that, if we don't have enough energy, we can just make some more. And myself and the colleague working together said, so you believe in perpetual motion machines, do you? He went, what? He said, you cannot make energy. It's one of the laws of thermodynamics. So you'll get people who've got PhDs in economics who will make comments about how the economy operates that effectively violate those laws without being aware they're actually doing it. So, and one of the ways it starts is with an organising concept like the circular flow, because if you look at a circular flow diagram, it treats the economy, most of them treat the economy in complete isolation from the environment. So here are a few samples. This one, a nice little supply and demand curve everywhere. I think I stole this one from Manque. Anybody got a copy of Manque? Yeah, what do you use it for? I find it keeps doors open really well. So supply and demand curves everywhere. Goods and services flowing this way, factors of production going the other way, payments, etc., etc. Okay, here's another one. So you have income flowing one way, loans, includes the financial sector here, taxes, government, etc., etc., etc. There's no non-economic input there, and there's no non-economic output either. There's nothing happening coming in from the environment into the economy, and there's nothing going from the economy back into the environment again. So all the inputs here are produced by the economy itself, and all the output is consumed by the economy. Now that is implying that the economy as a system can produce increasing output over time. And it can also absorb everything that it produces. Both those statements are false. We've got an organising concept of how we think about the economy, which is false. First of all, you can't produce more output over time out of a closed system. That defies the second law of thermodynamics and the first. And you must produce waste. And to say you don't produce waste is defying the second and the third laws. So the way we think about the economy, starting from this so-called organising concept, is actually quite wrong. And the only reason we can actually have what we call a circular flow is because that circle is being turned by energy. If you didn't have free energy coming in from somewhere, then not only would you not be able to have an economy, none of us would exist. Life itself requires energy, so I'd see production as an extension of our capacity to use energy as life forms. So there's three basic forms. There's solar energy, of course we're actually enjoying it in London. By the way, who expected London? Who's a non-London born person here? Who expected miserable weather? Have you been getting it? I find we get blue skies all the time here. I thought I'd be suffering vitamin D deficiency by moving from Sydney to here, but it's been quite a pleasant place, much to my amazement. So it gets plenty of solar energy, not very hot, but it does get it. Okay, and then you have fossil fuels which can store energy, of course, and nuclear energy, which is the leftover of supernova explosions. So those are the three large forms in which we can take energy. And of course, our transformation, really, our initial beginning as species, simply used solar energy. There was no other way to use it. We started using, when we invented fire, we started using recently stored solar energy. We started using fossil fuels sort of around the 1800s, 1700s. Nuclear, of course, in the 1900s. But all that stuff exists independent of humanity. We cannot make it. That's the first law of thermodynamics. It says there's a certain amount of energy and that's all that exists and we can't produce any more. There's some, has anybody heard of what's called zero-point energy? Okay, so there's some, elements of physics which talk about maybe there's ways to generate energy elsewhere, but that's way in the If we get there, it'll be in Star Trek type time. So we can only exploit energy that currently exists, and that includes converting matter into energy, which is nuclear power. Now, when you do it, you necessarily generate waste. So the whole idea that you can have waste as production is nonsense. Okay? You simply can't do it. You can minimise waste, and certainly we've been doing a bit more of that over time. And those are the second and third laws combined. So if you're going to make that so-called circular flow diagram realistic and actually integrate economics with the real world, which is where it should be in the first place, you've got to add energy inputs from the not man-made environment, and you have to have waste injected back into that environment. That's the minimum to make that diagram at least beginning to be realistic. So something like this makes sense. You're going to have either the sun or fossil fuels or nuclear energy, and that's something which pre-exists, which we then trigger and exploit. So the energy comes into the system. That then enables useful work to be done, which enables this production cycle to occur, distribution and so on, and we also generate waste. So that's your minimum to start making it look more realistic. Now, why can't we produce without using already existing energy and produce without producing waste? Well, that's these laws. And as I've said, they're empirically and theoretically completely confirmed. They're probably more certain than the theory of relativity or the theory of quantum mechanics, because those two theories are actually partially in conflict. And thermodynamics, it's complete. So they're empirically true rules about energy and work. And so discovered in the late 19th century. I got that one right, that's good. And that was after Marx developed the later theory of value. And it was as neoclassical economics was developing in reaction to the classical school being taken over by Marx. Again, if you look at the development of neoclassical theory, you had Corno and Say, who were two dominant neoclassical type personalities prior to the development of the neoclassical theory in the 1870s. But overall, the whole way through, the classical school was dominant. So Smith was a classical economist, Ricardo was, but you started getting a breakdown of this when Marx turns up and starts using the classical theory not as a reason to explain and celebrate capitalism, but to explain and critique capitalism. And then the neoclassical school began to develop at that stage and became quite dominant in the 1870s. And if you look at what they were trying to do, a lot of what they were looking at was the physics they understood. And the physics they understood, and this makes eminent sense when you think, get rid of the internet, get rid of Wikipedia, take yourself back to the 1870s. You're reading books which are 20 and 30 years old if you're lucky. Unless you're actually a physicist on the fringe of actually pushing the theory forward, you're not going to be reading a book which includes the latest physics, period. So the physics they were learning was before physicists in the 1800s had developed the understanding of thermodynamics. And the first guy developing thermodynamics actually committed suicide. Partly he was a manic depressive, I think, but also he was so annoyed that he couldn't get physicists to accept his theories. So physicists themselves hadn't completely integrated this thought. It's not a criticism of economists to say that they were basing themselves on a dated version of physics. My real criticism of economists today is they're still basing themselves on a dated version of physics 1.5 centuries later. It's about time we broke out of it. Now, to really understand the laws of thermodynamics, you need quite advanced mathematics. I can teach myself that stuff when I need to do it, but I forget it afterwards. Okay, it's just one of those things. But there's a nice mathematics joke. You know, mathematicians have a sense of humour. Okay? This is one of my favourite. This is actually this is a wonderful. Suddenly, I'm forgetting the names. I'll have to come back with that one later. I've got a bit of a cold right now, so my memory's losing a bit of sharpness. But the joke version was developed by an English writer, C.P. Snow. C.P. Snow. And Snow is both a novelist and a physicist. An incredibly unusual combination. Somebody who was a leading physicist, experimental physicist, theoretical physicist, who also wrote novels. So he lived in two worlds. And he said what he found was these two worlds didn't understand each other. I think he called them the two cultures. One more late arrival. He said physicists didn't understand, didn't read Shakespeare. Well, the attitude of his literary friends was that physicists were dumb because they didn't know Shakespeare. He said the physicists' attitude towards the cultural people was they were dumb because they didn't know the laws of thermodynamics. So C.P. Snow was somebody who was eminently able to say, well, I can explain these theories. He said, anybody who regards themselves as an educated person and doesn't understand the laws of thermodynamics is as ignorant as somebody who regards themselves as an educated person and doesn't know Shakespeare, Mill, etc., etc. Okay? So his joke version was you can't win. That's the first law. The second law is you can't break even. And the third is you can't leave the game. Now, would you play a game like that?
Yes.
You are playing it, okay? You have no choice. Now, a slightly more informative version of that is that you can't win, you can only break even, okay? You can only break even if you can find somewhere in the universe which is at a temperature of absolute zero, and there's no such place. That's the basic idea of these three laws put together. So a translation, the first one is you can't create or destroy energy. So we think you go into a poker game, you want to come with more money than you went in with, okay? But you might be able to do that, but the game as a whole can't, okay? The poker game will redistribute the money that exists. It won't create any more money in the process, unless you've got somebody who works in the banking sector. Long story. So only the form of energy has changed. We take energy in, we transform its form, we don't create or destroy it. So the sunlight coming in here, as weak as it might, as strong as it might be, is converted in the process of us absorbing that into infrared, which is a conversion of the form of the energy. The total amount of energy remains the same, the form changes. The maximum of energy you can use to do work depends upon the background temperature of where you're doing it, because work is really using energy to push something. Okay. Now, you're not going to push something when there's no difference between the temperature you're starting from and the temperature you're getting to. So the background temperature matters. And only if the background temperature is absolute zero can you use all the energy that exists in something. So if you took your car into outer space, okay, you'd get about 300 degrees more, 210 degrees here, degrees more temperature, power out of the engine than you can get here. But you can't do that, of course. And the final law is there's no place in the universe that's actually at the level of absolute zero, so there's nowhere to exploit all the energy that exists in any free energy source. So this therefore says you're wasting some of the energy you can't use. And why is that inevitable? Well, to use energy, you have to turn potential energy into work. So, for example, a watermill, and I found this wonderful animated GIF, and it bloody well annoys me that wheel's not turning. But the basic point is you can only turn the wheel because the waterfall is above the level where the water goes down to. Okay? So, I wish the person would retake. How did they do that? They must have just locked the damn thing. They took a photograph of it, a movie of it, when it wasn't actually being used to turn the water wheel. But of course, if that water was at the same level as where it's falling to, there wouldn't be any potential to turn the wheel. You've got to have that physical gap there to make it possible to actually use the energy. And of course, how much energy you can get out of it, well, it depends on how tall this is. Now, if you wanted to exploit all that energy there, you'd need to have a hole here that went down to the centre of the planet. Okay? Which there's no such hole. Okay? So the basic story applies in general. The maximum you can extract depends upon the gap between the energy source, where you start from, and the energy sink where it ends up. So a waterfall can be a source of energy of power, which can be used to do work, if the height of that waterfall is more than zero over the water into which it's falling. And that same idea applies in general. You can only do work if the energy of your source is greater than the energy of the surroundings. And the basic idea is what's called a heat pump. So you're heating something up, generating heat. Maybe you might just have a stove and you've got a vessel and you're heating the vessel, and it's a sealed vessel. That has to be greater than where you're dumping the heat into when you've actually tried to do work using it. So imagine you've got an engine operating at, say, 500 degrees Celsius. I think that's roughly the temperature they work at. I'm sure engineers are going to write and correct me. And say the environment's 25 degrees Celsius, so you're not in London, you're in Sydney. Actually, apparently tomorrow Sydney's going to be 40 degrees. Okay. Well, there's going to be a flow of heat. You can effectively exploit a flow of heat between the 500 degree engine and the 25-degree environment in which you're dumping the energy. So there's energy to be harnessed in that situation. If instead you took that engine to Venus, where the environment is about 500 degrees Celsius, and you ran it, there's no flow of heat. You're just heating the engine up to the same temperature as the surroundings. So there's no possibility to harness any energy out of that. And that's the basic idea as to why both the source and the sink are necessary to be able to create work. So energy doesn't just depend on how powerful something is innately, how much energy is inside a lump of uranium or a lump of coal. It also depends on how cold the surroundings are. So you have the heat of the source and the heat of the sink, and your maximum usable energy is the gap between the two. That's the basic logic. So what's the coldest surrounding temperature? Well, it's absolute zero, and it's, in terms of degrees Celsius, it's minus 273.15. So that is the absolute coldest you can get something to. You know how they actually managed to get very, very close to that? I think physicists have got to within less than 0.001 degrees Celsius of that temperature. And how they do it? They'll suspend atomic particles between laser beams and stop them vibrating. To slow the particle down to the stage where it's as still as they can possibly make it. And that really is the definition of zero, very, very close to zero. But they can't get there. That's the third law of thermodynamics, is you can get very, very close, but you cannot achieve absolute zero. And when you look at the universe and say, what's the average temperature? I mean, the universe is basically fundamentally empty space. Okay? Planets and suns, of course, exist by their trillions. But across the entire universe, the average temperature is about 2.73 degrees above absolute zero. That's even if you're floating around, outside the Oort belt. I think Voyager's out there now. The temperature of Voyager is probably operating at is about maybe 2.7 or 2.6 degrees Kelvin. So there's nowhere in the natural world that's absolute zero. They're about 2.5 degrees above absolute zero at the minimum in the natural world. And in physical experiments, the best physicists have done it. I'll find out what it is, but it's of the order of 0.001 degrees above absolute zero. Now, the average temperature of the Earth is about 16 degrees Celsius, which is about 292 degrees above absolute zero. So London would currently be about 285, I guess, or 280. So on Earth, about 290 degrees of any energy source, heat source, can't be used. We're going to be dumping... Is there somebody else coming in? Or? No, I'm out to the other room. Okay. So about 290 degrees of the energy can't be accessed. So at least that much potential energy is wasted by any energy source we're using on the planet. So even if you have an ideal engine, no friction, no leakages, the maximum efficiency must be less than 100%. And again, this is one thing I find irritating about neoclassical economics. They have this obsession with eliminating waste. Perfect competition, that nonsense concept. They talk about consumer surplus being 100% of what it can be, and producer surplus 100% of what it can be, and efficiency, etc., etc. It's nonsense. Physically, there's no possibility to use anything to complete efficiency. And engineers are used to this. So engineers will learn that your real maximum amount of work can be related to the heat of the source and the heat of where you're dumping it. And the work, you can say that the efficiency of that perfect engine is going to be 100% minus the heat of the dump divided by the heat of the source. So if you have an engine that's operating at, say, 1,000 degrees Kelvin, you've got to work from absolute temperature, not Celsius, which is just happens to be the melting point of water. Okay? It makes sense on this planet. But for a really universal measurement, you use degrees Kelvin. So the source is, say, 1,000 degrees Kelvin, which is about 700 degrees, a bit under 700 degrees, a bit over 700 degrees Celsius. And the dump is 300, which is about like a hot summer's day in England. Then the maximum efficiency of the engine is going to be 70%. Then you've got to take off other elements for friction, etc., etc. But even if you've got zero friction, which is impossible, and no leakages, which is also possible but difficult, you'd still have a maximum level of 70%. So perfect efficiency is impossible, even with an ideal engine. And Carnot was the one who first worked it out with a wonderful theory of a heat pump. I haven't actually put that in these lectures. If you'd like me to explain that, let me know. But I haven't included that in this particular set of lectures. So the actual wastage will be higher than that. Now that's the very beginning, because it gets worse than that. That's just effectively the first law in some ways. If you're going to use that heat, then you have to extract the energy from that source and use it in some way. So you have to have an open. The system has to be dumping its waste somewhere. If it doesn't dump its waste, then it can't exploit the energy it's got inside it to begin with. So a closed system, if you have a system which is completely sealed, then you're not going to get energy out of it, because power generation will only work if you can dump the waste heat into the environment. So if you look at a stylized model of a power plant here, you have a boiler over here where water's being pumped in a cycle through it, heated here by coal or gas or something, drives a turbine, then a condenser cools it down and it goes back in again. So this section is all sealed. But the condenser here is taking superheated water here, cooling it down, and then putting cooled water back in here again to repeat the process. So this thing over here is absolutely essential to enable it to actually get energy out of it. So that generates the power, but it only does so because the waste heat is dumped here. Now, if you sealed it off, if you actually completely isolated that from the environment, then what you would get over time is the temperature would become even around the whole system. A turbine wouldn't turn. Okay? So you've got to be able to link that turbine with the external world by dumping the waste heat. You want to get back to this stage. After the turbine, you want to cool it down here. If you don't do it, then you won't get any work out of it. The turbine won't spin. So that implies, in general, a closed and an isolated system will go from a high level of order to uniform order over time. And this is one of the most complicated concepts to get your head around, and I always get it wrong. Okay? Don't kick yourself if you make the same mistake, because the way the terms were described, I think, is we could have used a different convention for saying what was high and what was low. But high becomes low and low becomes high. We're always swapping those words around. So a high degree of order in a system is called low entropy. Okay? Whereas a uniform system where everything is exactly as smoothly as it possibly can be is called high entropy. So I find I stumble over that all the time, and I see physicists talking about it over a few beers will be willing to say the same thing, that they find it's a conceptual, complicated thing for our mind to associate low and high at the same time. So we get confused with it. But the basic idea is that low entropy talks about things being highly organised. So if you imagine you have a piston and you push that piston in the air in this room, imagine you had a sealed piston and you pushed it so all 95% of the air was here and 5% back there. You guys would all be struggling to breathe. Okay, that's a highly organised state because most of the materials here, a very small amount of it, so that's a highly unusual state. Of course, if I let that piston go, what's going to happen is the pressure will do this. It'll move it all around until it's even on both sides, roughly even, because there'll be some unavoidable friction with the piston as well. So that's the basic idea of going from low entropy to high entropy, which is from high order, very organised, to messy. Okay, and that's why it's so hard to get your head around that verbal concept. So high entropy is a fairly uniform pressure, and that's a universal tendency. If you have a sealed unit, no energy coming in from the outside, then over time this sort of change will occur. And it's easy to think about it in terms of a gas, which is where these ideas often originated. Because if you can imagine this one as well. You can find cartoons and everything on the web. So here's a little girl explaining why the rooms are messy. You can't fight the second law of thermodynamics, which pretty much describes my bedroom. So you go from a state of order to disorder. That's, again, the way that it's portrayed. So, back to economics again. The two key things out of it. First of all, you can't eliminate waste. You can reduce the degree of waste, but you can't eliminate it. So that makes an intimate link between ecology and economics. And if I had to give any task which your generation of economists, for those of you who want to become professional academic economists, any task to really do properly, it's that. Okay? The beginnings of, and in some ways what I'm covering here, I hope there's some ideas about what to do. You won't find any school of thought that's done it properly. Even environmental economics is not well enough developed yet at a technical level. People who work in that area are certainly conscious of this issue, far more so than neoclassical economists or post-Keynesians in general. But they still haven't got a completely developed alternative. And secondly, energy is essential for production to occur. But when you look at it, what production is doing in some ways is going, sort of colloquially, in the opposite direction. Because we're taking in stuff which is disorganised, raw materials like iron ore, and turning it into steel. Okay? So that looks like we're going in the opposite direction. We're taking disordered stuff, we're making something ordered out of it. Now, since an unbreakable law of the universe, that disorder rules, then production has to be also increasing disorder, even while it's creating products on this planet. Though what we look at is the refinement we're doing at a level of looking at the energy processes that are going on. Production has to be increasing disorder in the aggregate once you include the waste as well as including the products we take out of it. So this whole question of how do we produce a surplus, which is where I'm beginning from value theory, we have to make that compatible with the second law of thermodynamics. And we don't as yet do it to answer that question. That's not a bad point to take a break at. So let's take about a 10-minute break and come back? Okay. Part of the lecture, and we'll have a bit of time for discussion afterwards. We had an interesting philosophical point asked about the difference between the behaviour of the physical sciences and the social sciences. We might actually raise that and talk about that in the tutorial section. But the question is, and that's why I posed the thermodynamics to begin with, how do growing economies produce a surplus? How do outputs exceed inputs? And they're more ordered than inputs. If you think about our inputs are things like steel, you produce iPhones using that, getting even more refinement going on in production. Now, a surplus in an isolated and closed system is simply impossible. That's the whole point of the laws of thermodynamics, and that system will degrade over time, which is the second law. So it can only produce because the Earth is an open system. And that means it's receiving incoming energy from the sun. And if you think about where not just human production began, but life began, it's by exploiting that free flow of energy. If that wasn't there, nothing would exist at all. So over time, we started using stored fossil fuels. So really, there was some use of coal, thousands of years ago, I'd imagine. But really the heavy use of coal only began in the late 1700s. And most production, if you think about how people actually ran furnaces and stuff like that, because we did have furnaces to smelt ores, of course, right back from the days of the Copper Age, that was pretty much using wood rather than fossil fuels. So it took us a long time to get onto fossil fuels. Of course, nuclear energy, we only began using that in any real sense in the late 1800s, and we started discovering properties of radium and stuff like that, and we still haven't worked out how to use nuclear power properly for producing power these days, when you look at how unsuccessful most of our attempts have been to use it reliably.
They made a fusion reactor in Germany.
Pardon?
They made a fusion reactor in Germany.
There's actually a huge project involving about 7 countries trying to build a fusion reactor.
Yeah, they did a small one.
Yeah, but it's only, in terms of getting energy out of it, for a sustained period, we're talking microseconds. We're not talking... When you start talking minutes, then we're serious, okay? When you're still talking microseconds, you're saying for a short time we can maintain those conditions, but we're still a long way away from it. Now, what we're doing with our farms and our factories, we exploit these sources of energy to produce more outputs than inputs, in terms of, and more order in those outputs than inputs, but we're necessarily generating more disorder at the same time. And there's a lot of physicists, again, over a beer, will argue that maybe life itself is a way of dissipating, creating more waste than you create without life. In some ways, the universe is speeding up that second law. Okay, we create more disorder. So this is the entropy of the outputs and the inputs is going to be exceeding the entropy or the disorder of the inputs. That's a given. We can't escape that. Now, to revise what economics currently does to comply with those laws, we have to start by saying the economy and the environment are necessarily linked, certainly as long as production remains on the planet. Okay? I think at some stage we're going to take production off planet. If we don't, we've had it. But at the moment, production occurs here. We necessarily use energy to produce that output. and that's labour and capital. First of all, they can't produce energy. Okay? You can mine energy, you can't produce it. I think that economist who made the kind of using labour and capital to produce more energy really, if he was doing any thinking at all, was thinking about, building a mine somewhere and digging up some existing fossil fuel, that sort of thing. Okay, and you can't substitute it either. Okay, you cannot substitute labour and capital for energy. You can use energy more efficiently by changing the nature of your capital or changing the nature of your labour. You can more efficiently exploit it, but you simply cannot substitute one for the other, and you can't produce without energy. So all those things, and I just realised these little couple of lines a couple of days ago. Labour without energy is a corpse, and capital without energy is a sculpture. Okay? The whole concept of being able to have any of these without energy is nonsense. So when we draw an equation, a mathematical equation, we have labour and capital. What we're intellectually doing in some ways is imagining that they can exist and do something productive without energy. If I took all the energy out of one of you, I'd be saying your final rights. You'd be dead. Okay. So we can't exist without it. We ourselves have stored energy. I'm using it right now. You are as well, using that stored energy. Machinery at the same time. So what you can see labour and capital as means by which we can use embodied energy to perform work. If you go right back to really, imagine we started with slave societies initially after the period of Cro-Magnon tribes, and you had the development of slave tribes at the time before. Let's say we don't really know which did we do first. Did we domesticate animals or did we start domesticating ourselves? Nobody really knows the answer to that question on the development of primitive society. We probably started domesticating animals first. But what we're doing is using embodied energy to do that, directing the energy existing in some living being to do work for us which makes something we want to consume. So you have to have at least three types of inputs. You have to have energy from the open system of the planet itself. It's solar energy coming in, energy which is being stored in the living being, whether that's a human or an animal, and you then get that to do work. You direct that energy to perform something you want to perform, to make something you want. Now, of course, we're using not just direct solar, but also direct solar, stored solar, and nuclear energy. So you need energy, you need labour, and labour has to have energy in it. You have to have some calorific content inside you that you can actually exploit to get work done. So again, energy and labour are linked in that sense. And the same for machinery. If you have a factory with no energy anywhere in it, it's not going to produce anything, no matter what it is. Okay? So there has to be an energy source as well. And this is what I'm thinking about as a way to try to generalise things like a Cobb-Douglas production function, which imagines you can produce without energy. To say we've got to include the energy, but it's got to be embodied in the labour and the capital, which means you can't substitute for it, which is the current myth that we get as well in terms of how we treat modelling production. Both the neoclassicals with the Cobb-Douglas production function approach and post-Keynesians using labour and capital as inputs are implicitly talking about production without energy. Now, the post-Keynesians have what one saving grace on that. They don't talk about being able to vary the labour-capital ratio all that much. Whereas the neoclassical vision imagines you can produce huge amounts of output with a huge amount of labour and a small amount of capital, or a small amount of labour and a huge, swap the two around, produce the same level of output, smoothly substitutable. And that implies also a smooth substitutability between the energy embodied in the labour and the energy embodied in capital. That can't be done, it's just wrong. So we have three types of outputs as well. You're going to transform matter into useful products and services. That's the whole intent of production in the first place. We're going to have waste energy, and that's the whole thing about the second law of thermodynamics, that there's going to be energy you can't utilise that's in the energy source you use to get work done. And also, we're going to have waste products. When you burn coal, you're going to produce carbon dioxide. If you actually wanted to use that carbon dioxide, it's going to take you more energy input than you get out of it. Okay. We talk about sequestrating carbon and all these, I think, nonsense ideas about clean coal that are part of the reason we believe we can actually avoid serious damage to the ecology with rising global temperatures. I mean, just it's a farce. But to actually get rid of that stuff, we're going to put more energy in than we get out. So that's therefore definitely a waste product. And there's many waste products as well. Now we can reduce some of those waste products by changing our technology. So, for example, if you look at a car engine these days, the car engine is made by punching holes in steel and throwing away the scrap, etc., etc. If you actually made it using 3D printing, then you wouldn't have that machine tool waste, but you'd still have other forms of waste. And then finally, there are some irreducible elements you simply can't get rid of. Things, the strontium-90 is not something you want to try to find another use for. So to try to visualise this, you have to embed the economy in the biosphere. We start from saying we're on a planet with the living forces and so on. We produce a surplus because we're harnessing all this free energy coming from three fundamental sources. We have the sun, we have stored solar energy in the form of fossil fuels, and we have stored cosmic energy in the form of nuclear products which can be used in fission processes to produce energy as well, and that's out of the explosion of supernovas. That useful work powers the economy, and you need labour and capital to harness that and to produce output. So that's a useful work. But because of the laws of thermodynamics and reality, you have both physical and energy waste, which are both necessarily generated and also due to inefficiencies. We can reduce the inefficiencies, we can't reduce the necessary component of that, and it involves a state of technology as well, changing over time, but we'll never get rid of that core of waste. So that's dumped back into the planet again. So that's at least a beginning framework to say how we can conceptually think about production and producing a surplus and so on. And of course the catch for us, which is where the carbon dioxide issue is important, is the biosphere is going to slow the transmission of that waste energy back into space. And a tiny increase in the rate at which we slow that back is what's causing that increase in our background temperature level. And the biosphere itself is affected by waste. If you dump that waste back into the biosphere, then you can undermine the production processes themselves. Has anybody here read the limits to growth? Nobody. Have you heard about it? Okay. I'll actually bring that up right now, because this to me is going to go down as one of the seminal works of human endeavour, which was completely trashed by economists, and in fact they were right about the nature of these feedbacks. So you can actually get a copy of the Limits to Growth. It didn't take me long to find it there. There's a 1973 study looking at all the feedbacks that exist between production, waste, population growth, etc., etc. Highly recommend. I more than recommend reading it. Read it. Period. Okay. So if I was going to go in from an environmental course, I'd go more into that detail right now. But what I want to cover here is the whole idea of production, surplus, and getting to financialisation ultimately. Can we make economics consistent with the laws of thermodynamics? Well, I don't believe the neoclassicals can. For a start, they're seeing the source of surplus as an increase in utility. Now, they don't explain how that's possible, and they're effectively taking the physical processes that enable that for granted when those physical processes have to be explained in the first instance. And they'll use production functions that argue that output is a function of technology, labour and capital, which is the classic Cobb-Douglas production function. Now that implies a smooth substitutability between labour and capital, and that becomes part of their explanation for the distribution of income as well. So if you fix it up and say you can't have that, you have to have energy in there as well, and it must be there in a non-substitutable way, so therefore you can't get your distribution to be linked with that production theory either. There must be a gap. Okay, so it's leaving out any implicit role for capital. Energy, treating energy as another form of capital, which it's not, because you can make a machine, whereas you can't make energy. And their production function is the mirror image of their model of consumption. Really, they began with a model of consumption, and they then tried to generalise that to a model of production. So you had in difference curves, you've got isoquants. Okay? Budget lines, you've got technology constraints and so on. The model of consumption, it's fair enough to say you can substitute commodities for a level of utility to some extent. There's big problems with it, which, if I'm covering the course in history, if I thought I'll go why it's got huge flaws to it, but it's not inherently wrong. Okay? As a model of consumption, it's okay. Not good, but okay. As a model of production, it's nonsense, because it argues the same substitutability that applies in consumption can be applied in production. No, it can't. Okay? So it's inherently wrong at that level. So I don't believe you can reform. If neoclassical economics properly integrated energy, it would cease to be what can be called neoclassical economics, because its distribution theory would change, etc., etc. And it also has this obsession with perfection, wasteless production, etc., etc. Forget it. To have a model of the theory of the firm that aspires to wasteless something or other is to aspire to something which can't be achieved in engineering. So it's nonsense. This is their theory of income distribution would go, because they talk about factors of production receiving their marginal product. That's just not possible. When energy is part of it, energy is an essential part of production. You can't produce it, but it doesn't get paid at the same time. That's where your profit is coming from. So they have a theory of where incomes are completely accounted for by the output. When you include energy as a non-manufactured necessary input, that's no longer happening. And that can also be seen, of course, as the source of the potential for profit in the first place. So you can't account for all of output, and you can't have the prices of the factor of production matching your marginal products. It just falls apart. So you can't make that theory conform to the laws of thermodynamics without completely transforming the theory's nature. So I think it's a dead end on that front. Now, only one school of thought's ever been close to being correct, and much to my amazement, I thought more of you would have heard about the Physiocrats. But it is the Physiocrats. And that's an 18th century school of thought which is centred on Francois Corneille, who was the doctor to the King of France at the time. And take yourself back to this period, it was when we were first starting to do autopsies, cutting open bodies to see what was actually inside them. There was an element of, the Mayans, if we developed a Mayan civilization, we would have known the contents of bodies. We would have decapitated, cut out hearts, etc., etc. Talking the Mexican civilizations 1,500 years ago, they knew the internal workings of the body because they had a different religion. But with Western religion, there was a sacrosanctness about the body. You didn't cut it open and take a look at a dead body until something in the 1700s. And then when doing it, they discover all these wires, We all know we have veins, we can see those, but seeing the arteries and how they link together, seeing the nerves, etc., etc. And the idea of circulation became an element that the medical profession was aware of, more so than the economists were in that sense. So the analogy that the Physiocrats began with had this analogy about a circular flow, working on the idea of the flow of fluids through the human body, as they now saw that happen courtesy of autopsies. But they also argued that surplus itself only arises in agriculture. And their logic was that is the only industry that receives this free gift of nature, being energy coming in from the sun. And this is a wonderful statement of the proposition. The husbandman, the farmer, is the only one whose industry produces more than the wages of his labour. He, therefore, is the only source of all wealth. And the soil pays in the immediate price of his toil. Now, the soil, of course, receiving energy from the sun, being where that gift comes from. But nature, what she grants is the physical consequence of the fertility of the soil. And that fertility of the soil, the fact the soil actually produces output, etc., etc., all comes from the sun. So, in that sense, they got it right. And what they then developed was an argument about the nature of the production system, starting from this basis that only agriculture produced a surplus. This is the original version of what's called the Tableau Economique by Francois Corneille. And what he did was he divided the economy into three sectors. So there's a productive sector, which is agriculture. That's where surplus is actually produced. He called the manufacturing sector the sterile sector. Okay? Manufacturing simply takes what's already been produced in agriculture and transforms it. So what he was looking over here was, he effectively talked about carriages. Okay, put yourself again back in the time of before the French Revolution with the nobility. He's talking about the manufacturing sector taking what the agricultural sector produces as a surplus and producing carriages for the royalty to ride around in. So there's your sterile sector. And then the other class in the middle is the king and all the retinue that the king supports. It's the third class. I don't actually mention it in the slides here. But agriculture captures that free energy. And when he wrote, that was fairly correct. By far the major source in which we used energy was solar energy for farming, and France, of course, was far less industrial than England was. Okay, so in that sense, they had an advantage that they weren't confused by industry, whereas I think in some ways Smith was confused by industry. So they predate the Industrial Revolution, and they also, certainly in France, even to some extent in England at the time, it predates the substantial exploitation of coal and oil. Now, Watt's steam engine began in, I think it was 1775, literally about a year before Smith published The Wealth of Nations. So Smith would probably have known of the work of Watt. They wouldn't have known of the importance of the work he was doing would have ultimately. But he was surrounded by attempts to use stored energy to produce output, and production was an essential part of what Smith was seeing in factories. The factory transformation is what he was observing. Because all this predates what we know about nuclear energy as well. The fundamental insight was right. They called the produit, I can't pronounce the French properly. Anybody French in the room? No luck there. Okay, produit net product. To produce the net product, which is what they focused upon all the time. They were right to say we're harnessing a source of free energy, and they're also right that predominantly that source was the sun. And the part that could actually use that was agriculture, which is what they saw very visibly at the time. So even though we look back and say, well, they're wrong to say that you can't produce a surplus in manufacturing, given what they were looking at the time, they made the right deduction to say that the net product is generated by harnessing free energy. So the whole question of value as well has been confused over time too. The value for the neoclassicals comes down to how do you set relative prices. The classical question was what is the source of profit? And I think in some ways only the pre-classicals asked the right question, which is how do you produce a surplus? How do you produce that physical surplus? You've got to answer that question first of all before you then say where does profit come from, and also say how can you increase the utility of the physical object. So how do we transform inputs into outputs where the outputs exceed the inputs in both quantity and quality? Lower entropy, etc., defying the second law, which nobody defies. I'd recommend clicking on that link, by the way. You'll get a Monty Python skit, which is well worth watching. Nobody expects the Spanish Inquisition. Okay? So the physiocratic answer was agriculture is exploiting the free energy from the sun. So that's the productive sector. Manufacturing, they thought, transformed that products into other forms. They called that the sterile sector. That was the logic that they had there. And then there's three classes. So the productive class, which is these are the husbandmen, as they call them in their writing, takes that free gift of nature, and it's easily to see the surplus in agriculture. And again, this is one reason why they were gifted in some ways by not being confused by looking at manufacturing at the same time, because in agriculture you plant a seed, solar energy is absorbed by the plant, it then takes the nutrients it finds in the soil and generates far more output than you get as input. So they're much more aware of this physical difference, because you're starting from corn, you're going to corn, but you're getting a massive increase in the amount of corn. So that whole idea of a physical surplus was an essential part of how they thought, and it was obvious when you looked at agriculture. Now, the industrial workers, they thought, took the value from agriculture and transformed it, but did nothing to add to it. They just changed the nature of it. And again, this has got echoes in what Marx argues later about the role of capital versus labour. So these things keep on turning up in some of our mistakes. And the proprietor class were the owners. Now, of course, and the owners in this particular case was the king, the emperor of England, the emperor of France. So they were wrong to think that the free gift only came from agriculture, but because they were writing in agrarian France before the Industrial Revolution and before we started to harness energy on a grand scale, then it made sense to see nature as the only way in which you could exploit that free energy. So with harnessing energy from an open system, which is the solar system basically for our species, we increase the order in the subsystem, which is the economy, we decrease it in the overall system, which is the ecology. That's the link we've got. Now, I think the physiocratic insight is where we should have started. And most people say they see Smith as the father of economics. I think Kane should have been the father. We got the wrong we based ourselves on the wrong person to go from Smith. Canave, I think, was a far richer individual to start from. So we started, first of all, we lost the focus on the physical surplus by Smith talking about division of labour as a source of value rather than energy, which is where the Physiocrats began correctly. We got even further lost when neoclassicals ignored the whole issue of the origin of surplus. So I've got a long way to get back to answering the question properly. So production is a process by which we take free energy and transform matter or energy into a lower entropy state which is more organised. That's the basic idea there. And we necessarily produce more waste than we produce output, and material waste is unavoidable as well. And with labour and capital can exploit the free energy that exists, okay? But they can't add value or exist without it. So in a fundamental way, your answer to what is value and how is more value created must involve energy. Now, the standard interpretation of Marx is false from that perspective. Okay? It says labour as that source. So I'm starting off saying thermodynamically Marx has got to be wrong, if that's all there is to Marx. But there's another interpretation of Marx that's compatible. It doesn't include thermodynamics, but it's not incompatible with it. And that's what I want to detail in the rest of the lecture, and that's Marx's what I call dialectical theory of value. So it's also compatible with post-Keynesians, who don't have a theory of value, but there's an implicit one in there, which is an objective orientation towards value. Now, post-Keynesians, as I've said, they tend to be agnostic about the whole value question, just because they tend to be a very pragmatic group, and what they saw was just a useless philosophical debate running around in circles between Marxists and neoclassicals. They didn't want to bother with it, and they basically dropped the whole question. And you get a couple of authors, an Australian guy there, Jeff Harcourt, whose work on the capital controversies is well worth reading. If you haven't seen that work, you'll check out Jeff's work on that front. But he also dabbled with methodology and wrote what he called a horses for courses paper, saying we should just use whatever works, which is a very pragmatic orientation. But at the same time, that use whatever works orientation is rather incompatible with their obvious question, interest in methodology. Post-Keynesians, even though they reject the theory of value, have an obsession about methodology at the same time. So there's a bit of an inconsistency there. And they also have a methodological critique of neoclassical economics. And obviously I played a fair role in promulgating that critique. Now, Backhouse wrote, I haven't linked the paper here, but I'll do that later in the next set of slides. But Backhouse made a very good point that he's saying if horses for courses apply, why should you never use a neoclassical horse? Okay. Because post-Keynesians refuse to use anything resembling neoclassical methodology at any point. And he's saying, well, if you're so pragmatic, why is it that our stuff is never pragmatically useful? I could give an answer to that question, but I think they do need to have a theory of value, and this one is compatible. What I'll be going through now, in the philosophical sense, is compatible with what Marx does, because there is an underdeveloped post-Keynesian alternative called organicism. These are a few authors, again, I haven't linked to the papers, but I'll do that for next week's class. And they argue that there was the philosophy that underlined how Keynes thought is organicism. And what's meant by organicism is that the essential characteristics of an entity, whatever that might be, are its relations with other entities. So it's not, you can't treat something in isolation. You can't have an isolated representative consumer and an isolated representative firm and work out your model. What really matters is the interrelations these entities have with each other. And therefore, if you have strict reductionism where you try to explain everything from isolated entities, then you're going to miss the essential nature of the economy. Now, I know this is. I'm going to come back to this point a few times, but yeah. Pardon? Organicism bit. Okay. Or it's just a word to describe a philosophy. And what the word is trying to say is that you cannot explain a social system by taking the elements of the social system in isolation and then trying to scale up from those elements. So if you think about how neoclassical theory tries to explain the market demand curve, for example, they give you a set of utility curves to describe the preferences of an individual consumer. They give you a budget line to describe the income of an individual consumer and the relative prices, and they then derive a downward sloping demand curve from that, and they scale that up to say that's the entire economy. Now, mathematically, that's failed. Now, does anybody explain what's called the Sonnenschein-Mantel-de Breuer conditions to you? Or not? Have you heard of that before? Okay. When you try to mathematically add up, if you have that model of an individual consumer, and you then say, well, that's an isolated consumer, you can derive a demand curve for that isolated consumer, can you then add up all the demand curves for isolated consumers to produce a market demand curve that has the same characteristics? The answer is no. Okay?
What did you call that before?
It's called the Sonnenschein-Mantel-de Breuer. So this is something you haven't also learned about yourself so far. Okay, hang on a sec. It's not exactly easy to read. But if you go and look for that, those are the names, Sonnenschein-Mantel and de Breuer. And neoclassicals haven't properly explained the whole logic of it, but check out the Wikipedia. This is bound to be written by neoclassicals, so it won't give a decent rendition of the whole theory. But it's basically proving that if you have a whole range of individual consumers who all obey the so-called laws of revealed preference, and you add up their demand curves, you can get any polynomial demand curve you like. So your demand curve, rather than necessarily sloping down, can have the shape that you can draw using a polynomial, a plus bx plus cx squared plus dx cubed, etc., etc. That's a valid demand curve. Now, that does not mean that demand curves wobble all over the place. It means the neoclassical economists can't explain why it slopes downwards. Okay? What they've left out of their theory is the distribution of income. Okay? They have a theory of an individual consumer with no relationship to any other consumer, so you can't say whether that consumer is wealthier or less wealthy than other consumers. When you add two consumers together, then you've got two agents who've got different incomes, and if you put them in a production economy or even what they call an endowment economy, they're going to have different endowments. So I give the example of Robinson Crusoe and Man Friday, you know, that classic story. And imagine that Robinson Crusoe and Man Friday are on the island, and Robinson Crusoe owns all the coconuts and Friday owns all the fish. Okay? And then you want to work out a demand curve for fish and coconuts in that economy. And then you take a particular set of relative prices. A price ratio between fish and coconuts. Okay? Imagine you're trying to derive a demand curve for Robinson Crusoe in isolation. And what you're doing is you're saying, I'm going to take a set of relative prices between fish and coconuts, and then see what demand that Robinson Crusoe has for coconuts, and then make the coconuts cheaper, and then see what its demand is there, and make them cheaper still. And what I'm doing is rotating to make that demand curve for the individual. I'm rotating the budget line while keeping the point of the budget line constant. But to do that, I'm saying that changing the relative price of fish and coconuts is not changing the income that Crusoe has. Nonsense, because the theory says prices set incomes. So as I do it, that curve's going to be moving all over the place, and therefore the aggregate curve I draw is going to be any old shape you like at all. That's reductionism. You've tried to explain an aggregate phenomenon, which is the shape of the market demand curve, where you expect demand for a product to fall as price rises. Okay? You've tried to derive it from an isolated individual. When you say it's more than one individual, you get an organic outcome, because changing one individual's income by changing relative prices changes the income of the other as well. Okay? So organicism is saying is an anti-reductionist philosophy. It's saying if you want to understand a social system, you cannot understand it by working at the level of isolated individuals. Okay? And that's what organicism largely comes around from that. Does that help? Okay. So they're missing this interdependence, and this also, when I talk about complex systems later, the same thing applies with complex systems. When you look at for example, this, believe it or not, is a complex system. I'll explain why in a couple of lectures' time. But to understand it, you've got to have an organic view. You can't treat things in isolation. Now that then gives you a problem. How do you actually analyse when everything depends upon everything else? That's the dilemma. Well, what Whitehead proposed was that there's a nested hierarchy of entities that matter. Yeah, thanks for that. And that nested hierarchy lets you analyse analyse at a particular level and expand to a higher level of detail later. So if you imagine you're starting with the overall context we have in this room, we're all human beings. Okay? That's more stable than the narrower context. Some of it might be entrepreneurs. Okay? Now, that means that when you're looking at the narrow context of entrepreneurial behaviour, you don't have to worry about the evolution of the human species at the same timescale. So you can focus upon a narrower context initially and then expand to a larger one later. And this is the idea of organicism, that if you're going to look at how entrepreneurial behaviour is going to change in the next 1.5 decades as we start having to cope with climate change, for example, then you can ignore how much humanity is going to evolve over the next 15 years as well. At least I hope you can. So there's an order, like I said, of an onion approach. You can start with a particular inside the onion and move out with more and more levels of complexity later. And that's actually compatible with Marx's Hegelianism. Marx's philosophical logic has got the same sort of structure. And this is a contentious field. I gave a course at New South Wales University a couple of decades ago with a good colleague there, Peter Kreisler, and we're talking about Marx, and Peter interjected saying he recommended students not to read the first 7 chapters of Capital. Start in chapter 8 and start going forward from there. At this stage I was still a junior lecturer and I resiled like Mark's doing right now. But I thought, if you don't read the first 7 chapters, you don't work out where his logic comes from. And the key logic I'm talking about actually I think happens in chapter 7. There's also, what's his name? The guy invented the term praxis. Can you help me out there, Mark? Pardon? Huh? Who? I can't get my hearings back, sorry?
You're not talking about praxeology?
No, that's the Austrians. No, they're different. A thing called praxis. There's a particular Marxist that people are into, Althusser. And he also recommended people not to look at the dialectics of Marx. People are saying don't read. My approach to Marx, and if anyone wants to read it, this is what I recommend. Start the very first thing he wrote, which is in 1844, called the Economic and Philosophical Manuscripts of 1844. Read him chronologically, rather than trying to read from some particular point. But certainly, if you're going to read Capital, start on page 1. You've got to learn the philosophy overall. So there's this huge disputes in how you even start to read Marx. As I said, my approach was ultimately chronological. I first read Capital 1, in a reading group like one Mark's involved in right now. We read more rapidly than you guys there, and got into fights within 3 weeks. But what people look at in Marx's philosophy is also quite confused, because people will often say that Marx's Dialectics talks about thesis, antithesis, and synthesis. And I said them slowly because I can never say those 3 words without stumbling over my own tongue. But that actually that's got nothing to do with Hegel or Marx. In fact, a guy called Fichte was actually responsible for that particular way of describing the dialectic. And there's an excellent book. I've linked 2 articles by a guy called Wilde here. There's one called Marx and Contradiction. I highly recommend reading that book. It's out of print. I think you can get second-hand copies on Amazon. But if you want to understand Marx, that I think is probably the best purely philosophical discussion of his dialectics. And I reached the same basic conclusion as Wilde had before I read Wilde. But it's one of the few times I've read a book and I think, yes, that says more succinctly and more completely what I thought about Marx to begin with. So a very useful book. So what you find is that Marx's dialectic are actually simpler than this thesis, antithesis, synthesis stuff, and actually more sophisticated at the same time. Now, he never spelled it out in detail, but it's implicit in his works. You have to read through. The most obvious work to understand what Marx was thinking about is called the Grundrisse. Has anybody tried reading that? Heard about it? Yeah. How far did you get? Okay. It's worth finishing. Yeah. But yeah. It's what is effectively Marx's self-taught notes, because in 1857, I think it was, he believed that the ultimate crisis of capitalism was approaching, and he wanted to write the theoretical work to support the revolutionary movements in the 1800s to guide them. And he went back and started rereading all of the classical economists he'd already read back in 1844 to 1846. So, and what he did was these copious notes were finally found and translated from the German and published as the Grundrisse, which means the rough draft. That's the most important work to read to understand Marx's logic. Now, when you apply it, I think it overcomes all the problems the classical school had. So it's not this thesis, cephas, etc. It's an idea that I've try to put a diagrammatic version of as well. But it's saying that anything you look at is a unity. Okay? You are, whatever state of mind you might be in as a human being, you're a social unity. You are independent. You exist independently of. You can be defined independently of the rest of the world, but you can't exist without it. So you've got an existence in your own right, but you're embedded in society at the same time. And that duality is part of our lives. So you can only be understood from a social context. Now, what society will do is focus upon one aspect of that unity. So if you go to a party these days, if you meet somebody new at a party, what's the first question they normally ask you?
What do you do? What do you want?
What do you do? Yeah, what do you do for a living? Now, if you go take yourself back 1,000 years and you went to what would pass for a party back then, what do you reckon the first question would be? You meet somebody you're in a traveller in a mead hall somewhere in England in 500 AD. Okay. What would you ask? Pardon? Potentially you're from around here. Where are you from? What's your rank? Absolutely. You ask, sir, are you a serf? You know, who is your master if you're a serf? Are you a lord, etc., etc.? Your social status matters. So different societies will focus upon different aspects of individuals. So that brings that particular aspect into the foreground. Now, if you go back to feudal days, your social rank is what's in the foreground. In capitalism, it's what you do for a living. It's your work that's brought to the foreground. Now, that doesn't eliminate the remainder of you. It seems the rest of you is pushed into the background. So if somebody asks you, what do you do for a living? And you say, I macrame most of the time, but sometimes I do chess. You're talking about whatever your passions, what inspires you, which, in this sense, capitalism ignores. So you're going to have a tension between what society focuses upon and the rest of you. Again, when you look back in the days of serfs and stuff like that, if a lord says, you're a serf, who is your master, you might pull out a sword in answer to that question. Okay, if you're revolting against the social system itself. So there's a tension between the foreground and the background that necessarily exists because society focuses upon one aspect of the unity, pushing the other aspects into the background. So you get a tension between the two. And if that tension is extremely powerful, which it can be at various times, then it can transform both you and maybe even the society itself. So I visualise it this way. Imagine that you have here's your society, and there's a unity. What's going to happen in society is it's going to focus upon one element of that, put that into the foreground. But that therefore means the other elements are pushed into the background and you have a tension between the two. So that's the basic vision that I see in Marx of how he organises his philosophical thinking. And it enables him to have that organicism that the post-Keynesians have been dabbling with but not completed some time. So what you get out of that, I argue, and Mark will be having a bit of a fight with me here, but that's cool, we'll do that later, contradicts the later theory of value, but is also compatible with thermodynamics and complex systems. And it enables you to organise your thoughts about how is a surplus produced, how is it distributed, what's the role of money, etc., etc., and gives me like an onion-like layer that gives me multiple interacting price levels, which also matters in capitalism. We have a price level for ordinary commodities. So the price you're willing to pay for wheat will be very different in nature to the price you're willing to pay for an iPhone, the latest version, etc., etc. Different elements will turn up in how you set up prices. You'll get complex dynamics coming out between prices and the distribution of income out of that. Now, I've got myself to the 1 hour stage here. I've got a feeling it might be a good point to stop on this set of lectures and carry this material forward next week. What do you think? Good time? Okay, well let's take a bit of a break and then have a talk about some of these philosophical aspects raised beforehand. So about a 10-minute break and come back then.